Greetings to Spring ISD's incoming 5th graders. This lesson will cover creating equivalent fractions using fraction bars. So what are equivalent fractions? Equivalent fractions have the same value even though they may look different. These models all have the same amount of the whole shaded. So these fractions are really the same. 1/2, 2/4, and 4/8 are all equivalent. Here's a quick song to refresh your memory of what equivalent fractions are.
If there were 4 socks to wear, then we would say there'd be 2 in each pair. And one of the 2 pairs we can declare equals 2/4 of all the socks there. Drawing 1/2 and 2/4 on a number line shows they can be described with an equal sign. An equal value is what they're worth, so we say 1/2 is equivalent to 2/4.
Equivalent fractions is the name for fractions whose values are the same.
Once upon a time there were 9 canaries on telephone wires sitting down in 3s. Each wire contained 1/3 of the bird, so 3/9 is equivalent to 1/3. Drawing 1/3 and 3/9 on a number line shows 1/3 equals 3 parts out of 9. Therefore, equivalent is the word that describes 3/9 and 1/3.
Equivalent fractions is the name for fractions whose values are the same.
If the numerator and denominator share a common factor, then you can divide the top and bottom by the same number, on top and under, and say with satisfaction we found an equivalent fraction. And you can multiply the top and the bottom by the same number, on top and under, which is really a fraction whose value equals 1. And through this action we find an equivalent fraction.
Equivalent fractions is the name for fractions whose values are the same.
The values are the same.
Equivalent fractions is the name for fractions whose values are the same.
The values are the same.
So let's see how this works. I'm going to show you how we use models to find 2 fractions equivalent to 1/3. First, I model 1/3 using a grid by drawing a rectangle divided into 3 equal parts and shading 1 part. Then, I'm going to add a vertical line down the middle of the model so that it is divided into 6 equal parts. But the same area of the whole is shaded. The second model is divided into 6 equal parts, and 2 parts are shaded, so the second model shows 2/6. Since the model of 2/6 has the same area of the whole shaded as the model of 1/3, 2/6 is equivalent to 1/3. Next, add 2 more vertical lines to the model so that it is divided into 12 equal parts, but the same area of the whole is shaded. The third model is divided into 12 equal parts and 4 parts are shaded, so the third model shows 4/12. Since the model of 4/12 has the same area of the whole shaded as the models of 1/3 and 2/6, 4/12 is equivalent to 2/6 and 1/3. This video will explore what we just went over in more detail. Check it out.
Look at the 2 length models below. Here in the top model, the whole is divided into 2 equal parts, and one of those parts is shaded. That means the fraction shown here is 1/2. Now let's look at the bottom model. The bottom whole is divided into 4 parts, of which 2 are shaded. This fraction is 2/4. Now if you look at the 2 length models, you will see that the total parts in both add up to the same length. Model 1 shows one part shaded, which is half of the whole, or 1 out of 2 pieces. Model 2 shows two parts shaded, which also means half of the whole because 2 out of 4 pieces is half. And the other way you can see this here is just notice that the amount of space in this length is the same. So the blue area is the same amount of space, even though the fractions look different. And this means that these two fractions here are equivalent to one another. They both represent the same amount. And in this model, each part represents 1/2. But in this model, each part represents 1/4. So what this means is that 1/2 is the same thing as 2 of 1/4, right? Two parts that are 1/4 each, or 2/4. And this means ultimately 1/2 equals 2/4. Now, even though the fractions 1/2 and 2/4 look different because they have different values in the numerator and denominator, they represent the same amount, so we call them equivalent fractions. Let's try a problem together to understand this concept better. Check to see if the fractions 1/4 and 3/8 are equivalent. Use area models. Now what you want to do is take the same whole, which is the same size rectangle, and divide one into 4 equal parts and divide the other into 8 equal parts. And that's what we have here, right? We've got one rectangular piece here that is divided into 4 equal parts, each part being 1/4, and we've shaded in just this 1/4 in purple. In the bottom model, you have 8 equal parts, and 3 of these equal parts are shaded in to represent the fraction 3/8. Now what you want to do is take the top model and show the same fraction, which is 1/4, but you want to show it with a denominator of 8, which means that we need to take each of these 1/4 sections in the top model and divide it in half to make 8 total parts. So if I do that, let's count and just see. I should have 8 equal parts, right? 1, 2, 3, 4, 5, 6, 7, 8. And now I have a fraction out of a denominator of 8. And when I do that, I still have the same area colored in that represents 1/4, but now it's 2 equal parts. So this is 2/8. And now we're going to compare this to the fraction 3/8. 3/8 and 2/8 are not the same. 3/8 is greater than 2/8, right? Because you not only have, this is just 1/8, 1/8, right? So you have 2 of these 1/8 pieces. But down here, these are eighths too, and you have 3 of these 1/8 pieces. So you have more area being taken up by 3/8 than 2/8. So these are not equivalent.
If there are any parts of this video you didn't understand so far, go back and repeat this part of the video or ask your teacher or parent to help you understand the concept. Now let's try one together. First, you'll need to draw a model that represents the fraction 4/5. Pause the video now to create your model. Let's see what you came up with. The model 4/5 should show 5 equal parts and 4 parts are shaded. Did you draw it correctly? Awesome, you rock. Now create a model that represents another fraction equivalent to 4/5. Pause the video again to create your model. You may have drawn a line down the middle of your model to create 8/10, or maybe you created a different fraction like 12/15. Either one is correct. Here's another one. Determine whether the following statement is true. 3/4 is equal to 12/16. Draw a model for both 3/4 and 12/16. Pause the video and do that now. Here is what your drawing should look like. 3/4 and 12/16 take up the same amount of space on the fraction bar. So 3/4 is equal to 12/16. Good stuff. Let's go on. Now let's try another one. This time, draw a model that represents the fraction 1/3. Pause the video now to create your model. Let's see what you came up with. The model 1/3 should show 3 equal parts and 1 part shaded. Did you draw correctly? Good job. Now create a model that represents another fraction equivalent to 1/3. Pause the video again to create your model. You could have drawn models to represent 2/6 or 3/9, or maybe you came up with something completely different. Keep up the good work. Now it's time for you to apply what you've learned and practice a couple on your own. Create a model to help find equivalent fractions for each problem. Take some time to draw out your models and come up with your answers. Pause the video now to work. Let's see how you did. To determine the fraction equivalent to 1/5, you should have drawn a model of equal size and split each fifth in half. So now 2 out of 10 parts are shaded. So 1/5 is equal to 2/10. For 2/3, you should have split each third into 3 equal parts. So now 6 out of 9 parts are shaded. Great job, you did it. For this problem, you will determine which fractions in the list below are equivalent. Really take your time and draw your models to help you with this one. Now let's look at each answer to see which fractions are equivalent. For A, it looks like 3/6 is greater than 1/3, so that can't be the answer. For B, the models show that 6/9 and 2/3 take up the same amount of area, so this answer is a possibility. We'll put a question mark on that one and come back to it. For C, 3/6 is less than 3/4, so that can't be the answer. For D, the picture has to be drawn very carefully, but 3/4 is slightly greater than 4/9, so we can eliminate that answer. So our answer is B. 6/9 and 2/3 are equivalent. Let's keep going. Last one. Use a model to help you determine which is equivalent to 5/10. Take a few moments to draw your own models to get your answer. Did you get it? Great job. You can use fraction bars to determine if two fractions are equivalent. The models show that 3/4 takes up more space than 2/3, so they're not equivalent. 3/4 is greater than 2/3. For your final challenge, you will complete the next problems on your own and turn them into your teacher. Pause the video and take your time. You got this. You can keep practicing by making up your own equivalent fraction models using fraction bars to determine if two fractions are equal. Remember, you can ask your teacher if you have questions or need help with this concept. See you next time and keep working hard.